Now today we'll study further, and we have seen about the cascading also, that we can even cascade the types of flip-flops. That is, if we are having a mod 6 and mod 10 flip-flop, we can even just take those flip-flop to design a bigger counter. Now this was the example that we were discussing in the previous class. Is this visible completely, everyone? Is the slide visible? Yes? Just say if the slide is visible or not. It's visible to everyone, right? Yes, is it visible? Okay. So I've just made it a full screen. So this was the example that we were discussing in the previous class, cascading of ripple counters. Now here we have seen that it works as a frequency divider also. That is, the counter works as a frequency divider also. Now here, since we are giving 60 hertz of frequency in the initial, we are giving 60 hertz of frequency, and when we are giving it to mod 10 counter will have exactly 10 states. 10 states is a mod 10 counter. Mod number defines the counter of the number of states it has. That is, it will work only for 10 states. That is from 0000 to 1001. 1001 is 9. So we start with 0 to 9. That will be a 10 states. Okay, that will be completely of 10 states. And mod 10 is a counter where we'll be having 10 states. Okay, so when we are giving 60 hertz to mod 10 counter, here I'm having a mod 10 counter. So when I'm giving 60 hertz to mod 10 counter, as we can see that here the 60 hertz is given to mod 10 counter, what would be the output? The output will be 6 hertz. That is, the output will be of 6 hertz. Now when this 6 hertz is given to mod 6 counter, here the frequency is getting divided by the mod number. Okay, so 60 hertz divided by 10 will be 6. Again, when the 6 hertz, this is a 6 hertz. 6 hertz frequency, when given to mod 6 counter, the output will be 1 hertz. Similarly, it can be taken in any of the form. Whether the mod 6 is taken first or mod 10 is taken first, that will not create any difference. Okay, so here in the second example, 60 hertz is given first to the mod 6 counter, the output will be 10, and when the 10 hertz is given to mod 10 counter, output will be still 1 hertz. Okay, so here it is making use of 4 mod counters, 4 counters. Here it is a mod 5 counter. When 60 hertz is given to mod 5 counter, 60 divided by 5, it's 12. Now the 12 hertz is given to mod 2 counter. This is a mod 2 counter. Now 12 hertz given to mod 2 counter, the output will be 6 hertz. 12 by 6. Now when the 6 is given to mod 3 counter, again the output is 2 hertz. Now this 2 hertz given to mod 2 counter, the output will be 1 hertz. That is how the frequency division is taking place by making use of counters. Okay, so is the concept of cascading clear? We make use of cascading the counter for frequency dividing actually. Okay, now it is very difficult to design completely mod 60 counter for 1 hertz output. So we have cascaded 2-3 counters accordingly as per our requirement and as per the availability of the counters. Okay, so this is how it is designed. This is a mod 4 counter and this is a mod 60 counter, asynchronous, which is a negative edge triggered. Yahan par bhi you can see it's a negative edge triggered, and this one is also a negative edge triggered. So this will completely work for mod 4 counter. This is a mod 6 counter. Now this one, let's start with the synchronous counters. Now in synchronous counters, as I've already said, what happens? The clock is given simultaneously to all the flip-flop. Ripple effect is eliminated completely. We don't have any ripple effect here. We make use of a common clock for each flip-flop and a combinational circuit to generate the next state. Clear? So the common clock is given to all the flip-flops. Now synchronous counters flip-flop with the same synchronous clock signal. तो सारे फ्लिप फ्लॉप को वी आर गिविंग द क्लॉक सिग्नल. वी कैन बिल्ड सिंक्रोनस काउंटर यूजिंग प्रोसेस टू डिजाइन सीक्वेंशियल सर्किट. हम सीक्वेंशियल सर्किट के थ्रू सिंक्रोनस काउंटर डिजाइन कर सकते हैं. 2-bit synchronous binary counter using T flip flop or JK flip flop. We can either make use of T flip flop or JK flip flop. As we have already seen, JK flip flop is also used and T flip flop is also used. So any of these can be used for designing any of the counter. Now these are the process, that is steps involved in designing of synchronous counter. Now there we didn't have to go for any of the steps. That was just how to design the asynchronous counter. We need to know what is the counter requirement, that is if it is a mod 6 counter, mod 9 counter, mod 10 counter. Accordingly we decide the number of flip flops required. Here also we'll decide the number of flip flops required for designing a particular type of counter. That is the first step, number of flip flops required. Now next is a state diagram. Now what is a state diagram? We'll explain it right now. Then the choice of flip-flops and the excitation tables. We have already studied about the excitation tables in the previous classes. Here again, we'll discuss it. Then the minimal expressions for the excitation and the logic diagram. These are the steps for designing the synchronous counter. First, we'll have to figure out the number of flip-flops required. Then the state diagram, then the choice of the flip-flops and the excitation table, minimal expression for excitation and the logic diagram. Now this is how we design 3-bit up-down counter using JK flip-flop. Now I have directly used up-down counter. Okay? Now this one is the state diagram. ये पूरा आपका state diagram है. Now what are we doing? We are making use of 3-bit. 3-bit, when we start with 3-bit, definitely it will start with 0, 0, 0 and it will end up to 1, 1, 1. So how many states are there from 0, 0, 0 to 1, 1, 1? Yes, tell me. How many states are there from 0, 0, 0 to 1, 1, 1? Yes, students, reply. How many states are there? Yes? Anyone? Just reply, just be with me students, because these topics are very, very important. If you will not understand, you will not be able to write a question of it. एक भी क्वेश्चन अटेम्प्ट नहीं कर पाओगे अगर आप नहीं समझोगे ठीक से. तो just be with me and try to understand whatever I am teaching right now. So if we have to design 3-bit counter, now for 3-bit counter, definitely we need to have 3 flip-flops. Clear? For 3-bit, because we want 3 outputs. 3 output चाहिए. So for 3 outputs, we need to have 3 flip-flops. And the states will start from 0, 0, 0 to 1, 1, 1. That is clear, right? So it will have 8 states. Okay? So here we start with 0, 0, 0. This is our first state. This circle defines the state. Circle defines the state. And inside we write the state number. That is, it is a state 0, 0, 0. Here we have written state 0, 0, 0. Now for up counting, we have made use of a mode. We have made use of a mode M. If it is up counting, the mode will be 1. If it is up counting, mode will be 1. Excuse me. Sorry. So what I've said right now, for up counting, the mode is 1. So it starts with 0, 0, 0 and it goes to 0, 0, 1. And again, up counting from 0, 0, 1 to 0, 1, 0. That is from 0, 0, 0 to 0, 0, 1. And the next is 0, 1, 0. And the next is 0, 1, 1. This is state 1. This is state 0. This is state 2. State 3. Again, the mode is 1. 1, 0, 0. State 4. This is state 5. It goes to 4 to 5 when mode is 1. So here we are writing the mode number, mode value, whether the mode is 1 or 0, because we are designing up counting, up counter and down counter both. So up down counter design kar rahe hain. So for that purpose we have made use of mode. Otherwise mode was not required. Clear? So here 0, 0, 0 say 0, 0, 1 and then it goes on completely with mode 1 to the next states. From 1, 0, 1 to 1, 1, 0, then 1, 1, 1 and again it goes to 0, 0, 0. So this will be the overall counting, that is up counting when mode is given 1. Now it may be in a reverse direction. If we start with 0, 0, 0 initially, the next state could be 1, 1, 1 when the mode is 0. Yahan par mode will be 0 and it again goes to the next state 1, 1, 1 say 1, 1, 0. The next the mode is 0 and 1, 1, 0 to 1, 0, 1 again the mode is 0. So this is how we'll draw the state diagram. State diagram is drawn in this way, that we'll first draw all the circles, that is defining the state of the counter. So here we have completely all states, all 8 states. So this is my first state, second state, third state, fourth state, fifth state, sixth state, seventh, eighth. These are my 8 states. Now for up counting, I've chosen M as 1. So when it goes from 0, 0, 0 to next state as 0, 0, 1, mode is 1. And from 0, 0, 1 to 0, 1, 0, again the mode is 1. So we'll just connect from the first state, present state to the next state. That is for up counting, the mode will be 1. All the modes where it is up counting, it will be 1. Now for down counting, 0, 0, 0, it goes to 1, 1, 1. And again from 1, 1, 1, it goes to 1, 1, 0. So for down counting, we have chosen mode as 0. For this, the mode will be 0. Okay? So this is how we'll complete our state diagram. Okay? Now let's see the excitation table. We'll see the present state, next state and the mode M. And this will be our required excitation. Now we'll see one by one. Q3, Q2, Q1. M. This is our present state with mode M. And this is our next state. So first of all, we'll write this part of the excitation table. That is the present state, mode and the next state. So the present state, if it is 0, 0, 0, the next state is 1, 1, 1. What is my mode? It's 0. 0, 0, 0 say 1, 1, 1 mein ja raha hai. The mode is 0. Then if it is 0, 0, 0 and the next state is 0, 0, 1, mode is 1. Now what we should do actually, we should take this as 4 bit of input. 4 bit of input 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1 and 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0 and accordingly. So accordingly, we'll write all the combinations of the 4 bit. ठीक है. So from here, from this combination and this combination, we'll write the next state. Whether the mode is 0, if mode is 0, it will be in the reverse direction, down counting. If the mode is 1, it will be in the next counting, that is the up counting process will take place. This is 0 0 0, it will be 0 0 1. If this is 0 0 1 and if this is 0, it will be 0 0 0. So from the state diagram itself, we can write this one. That is, what is my present state and what is the mode and what would be my next state. Clear? Is this part clear, everyone? I want a reply from everyone. Yes, reply fast, students, because this is very much required, because this is an important part. Are you getting this? Understanding the concept of the synchronous counter. Okay? So just be with me and try to understand the concept. Each and every concept is very, very important. So here we are taking the present state and the mode, and accordingly we'll write the next state. So we'll write complete table of the present state, mode and the next state by just seeing the state diagram. State diagram was very simple. As I've said, we'll write the states which is represented by the circle. Circles will have all the 8 states, and we'll connect the circles just by an arrow showing the mode. Mode is 0 when it is down counting, and it is 1 when it is up counting. So this is how it is done, the up counting process and the down counting process. So we'll write this table of present state, mode and the next state. Okay? Now let us see the required excitation part. Now this is an important, as we have already seen this. Q3. First we'll check with Q3. Q3 अगर 0 है, JK flip flop में will have 2 inputs, J3 and K3. For Q2, present state and the next state will have 2 inputs, J2 and K2. Then we have for Q1, we'll have J1 and K1. So for all the 3 flip-flops, these are the 3 set of inputs, J3 K3, J2 K2 and J1 K1. Okay? So in what will be our input excitations, that is the required excitation. Now when Q3 is 0 and Q3 next state is 1, what would be my J3 and K3? What happens when J3 and K3 it changes from 0 to 1? J3 और K3 में 0 से 1 कब होता है? In the cases when J3 and K3, here I am having JK. Okay? So what happens in the case of in JK flip-flop, let me remind you, when this is 0 and this is 1, what happens? The output is 0. That is, it is a reset state. When this is 0, this is 1, the output will be 0. It's a reset state. When this is 1, this is 0. It is 1. It's a set state. Now when this is 0 and this is also 0, it will be a no change state. And when these two are 1 and 1, it will toggle. This was just the revision of the JK flip-flop that we have studied in the previous classes. Okay? So what was JK flip-flop? When the JK flip-flop is 0 0, J and K are 0 0, it will be no change. If J is 0, K is 1, it will be reset. If J is 1, K is 0, it will be set. And when J and K are both 1 and 1, it will be toggle. So in this case, in the case of Q3, this one is 0 and this one is 1. What should be my J3 and K3? That is what we need to know. Q3 is 0, present state. Next state it is 1. So what actually it is happening? ये क्या हो रहा है? ये टॉगल हो रहा है. टॉगल हो रहा है मतलब इधर द J3 K3 कैन बी 1 and 1, दोनों केस में हो सकता है, और एल्स इधर J and K, इधर इट इज 1 and it is 0. वो दोनों के केस में ये 0 से 1 हो जाएगा. दिस वन इज 0 एंड दिस वन इज 1. तो इधर टॉगल का केस आएगा, this one when J and K are 1 and 1, or else when J is 1 and K is 0. So what is our excitation? That J is fixed 1. J is fixed 1. K can be either 0 or it can be the 1. So it is 1 cross. Is this part clear? This was the excitation that we have already studied in previous classes, students. Just we need to remind we just need to recall the things. ठीक है? So just remember, when this is 0, Q3 present state is 0, next state is 1. What should be the combinations of J and K? The combinations of J and K, either it could be 1 and 1 or it could be 1 and 0. So in both the cases we can see J is fixed 1, but K can be either 1 or 0. So we have taken 1 cross. Similarly for Q2 also, here it is 0, here it is 1. So J2 K2 will also be 1 cross. In Q1 also 0 to 1. So it will be 1 cross. So wherever it is from 0 to 1, it will be 1 cross. That is fixed. 0 से 1 हो रहा है तो 1 cross होगा J के combination. ठीक है? Now let's see for 0 से 0. 0 से 0 मतलब क्या होगा? When it is 0, initially it is 0 and the next state is also 0. Can anybody anybody reply? What should be the combinations? If the present state is also 0 and the next state is also 0, तो कौन कौन से combinations में होगा? J के combination can be either 0 0 or else 0 1. It can be the 0 0, no change condition, and this is a reset state also when J is 0 and K is 1. So in both the cases, either the present state is 0 and the next state is also 0. Both the cases, present state, next state 0 0 होंगे, तो our J K combinations will be, this is 0 fixed and K can be any value. So this becomes 0 cross. ठीक है? Is this clear? So here, in the case of present state 0 and the next state 0, our combinations, the required excitations would be 0 cross. Similarly, for Q2 also, we'll check individual values, Q2 in the present state and the Q2 in the next state. So Q2 in the present state is 0, next state is 0, this will again be 0 cross. 0 से 1 हो रहा है तो we already know it is 1 cross. ठीक है? Now again, for the next combination, 0 से 0, it will be 0 cross. 0 से 0, 0 cross. Now it is 1 से 0. This one, it is 1. Here it is 1 completely. And this one is 0. So what will happen for 1 with 0? If initially it is 1 and the next state is 0. मतलब ये toggle भी हो रहा है और reset भी हो रहा है. So in the case of toggle, मतलब either it is 1 and 1 or else this is 0 and this is 1. मतलब this is either a toggle state or a reset state. Clear? Here it is Q1 is 1 and here the Q1 is 0. So toggle, it may be the toggle state or a reset state. So here 1 is fixed, J is crossed. So we can see cross 1. Okay? So here we have got cross 1. So accordingly, we can write the entire required excitation for the complete table. Do I need to explain the complete table? Yes, students? This one is clear. How we can write the excitation table for this complete table. Is this part clear? Excitation table is clear or not? The required excitation? Yes? Is this one clear? Everyone, do I need to explain the complete table? Do I need to explain the complete table or you can write it? Tell me if it is clear, I'll proceed further. Because explaining the complete table will take much time. Do I need to explain the complete table or you'll be able to write it yourself? Yes? Tell me first if I need to explain the complete table. If any part is not clear, you can ask me right now. And if it is clear, I'll proceed further. It's clear? Yes, students, reply first. Clear hai? Okay. So I guess that you people will be able to write the complete table, complete excitation table based on the state diagram. Now, since we have written the excitation table, we'll find out these expressions. ये expressions बहुत important है. J3, K3, J2, K2 and J1, K1. Now because of this, with the help of these expressions only, we'll be able to design this diagram. Now with this one, with this excitation table, we'll need to see how these expressions are written. Now here, if I see J and K, if I see J1 and K1, it is all one cross. It is all one cross. That means there is no zero present in any of the J1 value and in any of the K1 value. So we can even consider it as completely 1 and 1. So that is what it is done here. If any of the 0 is present, in that case we cannot proceed with just 1 and 1. But here it is 1 and cross everywhere. We can see that in J1 also it's 1 and cross. In K1 also it is 1 and cross. 1 cross everywhere. So we have directly connected J1 and K1 with 1 directly. We don't need to design it. Okay? Now just we'll go for J3 and K3. Now we can see J is going high for this combination and for this combination. These are the two values where J is going high. So this is J3. J3 is going high for these two combinations. That is when all the Q's are high. That is Q3, Q2, Q1, 0, 0. Sorry, all the Q's are 0 with M0. And here it is going high when all the Q's are Q3 is 0, 1, 1 and mode is also 1. But we cannot directly write this by these two values. Here these are the don't cares. We'll have to find it out by making use of K-map. K-map के through we'll find out this expression. Okay? So how we'll find out the expression? By making use of K-map. Just wait, I'll just explain. Now here we'll draw the K-map. This is my K-map. Now here I'm having 4 inputs. This is Q3, Q2, Q1 and M. So here I'll take Q3, Q2, Q1 and M. This is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So this is how we'll draw the K-map, and accordingly we'll see where it is 1 and where it is don't care. हम don't care भी consider करेंगे. So कहाँ पर 1 है? 0 0 0 0. Here it is 1 and where it is 1? 0 1 1 1. That means it is at the position of 7. So this is 0 1 2 3. This is 0 1 2 3 4 5 6 and 7. At this point it is 1 and the rest of the values 8 9 10 8 9 10 11 12 13 14 and 15. These all are don't cares. So basically we are having two pairs here. We can see that this one is a pair combining with these two and this one is another pair. Okay? So here we are having two pairs. One is this one and another one is this one. This we are working for just J3. J3 के लिए ही कर रहे हैं. So for this pair, what is common here? It's Q2 bar. Q2 is 0. Here also it's 0. It is Q2 bar. And here it is Q1 bar M bar. Q1 bar M bar. Plus this particular pair. What is common here? Q2 and this one is 1 and 1. Q1 M. So this is how we'll get the expression for J3. This is the expression Q2 bar, Q1 bar, M bar, Q2, Q1, M. So this is how we get the expression for J3. Now similarly, we can even find the expression for K3. K3 का भी expression लिख लेते हैं. Now we'll see how to find the expression for K3. Now let me draw the K map again. This is how we'll draw the K map. This is Q3, Q2, Q1 and M. This is 0 0, 0 1, 1 1, 1 0, 0 0, 3 1, 1 1 and 1 0. Now we need to check the values of K3, where it's going high and where it is don't care. So from 0 0 0 0 till 0 0 1 1 1, all are don't care. That means all these are don't cares. ये पूरे आपके don't care है. It is going high for 8. That is 1 0 0 0. That means 8 comes here. This position is 1. And again at the position of 15. So this position is 1. So we'll be having two pairs again. This one is a pair and this one is another pair. So we'll write for K3. What is common here in this pair? In this pair we are having Q2 bar. Q2 bar, Q1 bar, M bar. Plus in this pair it is Q2, Q1, M. Okay? So this is the expression for K3. This is what we have got here. Q2 bar, Q1 bar, M bar plus Q2, Q1, M. Similarly, we can write the expression for J2 and we can write the expression for K2 also. And we have already written J1 and K1 are fixed 1. So based on these expressions, we will be designing this synchronous up-down counter, 3-bit up-down counter. Now we know that we have made use of JK flip-flops and 3 JK flip-flops. So let us start with designing part. So this is our J1, K1, first JK flip-flop. This is our second JK flip-flop. This is our third JK flip-flop. First of all, we'll connect all the JK flip-flops with a common clock. This is my common clock, which is connected to the clock of all the flip-flops. It's a negative edge triggered clock. Clear? So it's a negative edge triggered clock which is connected to all the flip-flops. J1, K1 is given fixed one. Now we'll be connecting our J2 and K2. J2, K2 expression is Q1 bar plus Q1 bar M bar plus Q1 M. So from here, we'll take a mode M. Now since it's an up-down counter, we'll take the mode. Here we have got the Q1 bar. यहाँ से Q1 bar गया. Since we already have Q1 bar as an output in the flip-flop itself, so we don't have to take the inverter of the Q1. Q1 bar हमारे पास already available रहता है. ठीक है? तो Q1 bar M bar. From here we'll take the M bar and Q1 bar ANDed plus Q1 M. From here Q1 and this is M. Both are ANDed and given to an OR gate given to J2. This is given to J2. Okay. Now since K2 expression is also same, Q1 bar M bar plus Q1 M. So this is also given to K2. Okay. So from here, on the basis of this expression, Q1 bar M bar, here I am having Q1 bar, Q1 and M, this part, and Q1 bar and M bar, both are getting ANDed and the outputs are getting ORed. So that is how we get J2 and K2. Similarly, we have to design for J3 and K3 also. What is it? It is Q2 bar, Q1 bar, M bar. Now from here we get Q2 bar. And we have already obtained Q1 bar, M bar. From here we get Q1 bar, M bar, which is getting ANDed to Q2 bar. यहाँ से हमें Q1 bar, M bar मिल जाएगा, which is getting ANDed to Q2 bar. So this is how we get Q2 bar. Q2 bar is given here. Similarly, Q2, Q1, M. यहाँ से we'll get Q1, M, which is getting ANDed to Q2. So here we'll get Q2, Q1, M. Here we'll get Q2 bar, Q1 bar, and M bar. So these two are getting ORed. And now since we can see J3 and K3, the expressions are same. So we can directly give the output of the OR gate both to J3 and K3. Okay? So this is how we have designed a synchronous 3-bit up-down counter using JK flip-flop. Is the concept clear, students? Everyone, this is how we design our JK flip-flop. We need to just go step by step. That is very important. First, we will draw the state diagram. सबसे पहले ये काम करोगे, ठीक है? As this is a 3-bit counter, we definitely know that we need to have 3 flip-flops. सबसे पहले तो ये पता करना है कि कितने flip-flops की requirement है. So we'll have 3 flip-flops. With since it is a 3-bit up-down counter, तो आपके पास 8 states होंगे. 8 states will be represented by 8 circles. Now it is up-down counter both. तो यहाँ पर हमें मोड की रिक्वायरमेंट होगी. अगर अप काउंटर ही होता या फिर डाउन काउंटर ही होता तो मोड की जरूरत नहीं पड़ती, ये पार्ट नहीं होता आपका. ठीक है? इफ इट इज जस्ट एन अप काउंटर और अ डाउन काउंटर, वी वुड नॉट रिक्वायर मोड हियर. ठीक है? मोड की जरूरत नहीं पड़ेगी. So in that case, we will just write the present state and the next state if it is just an up counter or a down counter. Okay? So in that case the mode is not required, but here since it's an up down counter both, we need to have a mode which says that depends on the mode whether it will count in upward direction or in downward direction. Here in our case, if it is मोड 1, मोड इज 1 तो अप काउंटिंग करेगा, और मोड 0 है तो डाउन काउंटिंग करेगा. वी कैन टेक इट इन अनदर वे ऑल्सो, दैट इज अप टू अस. ठीक है. सो द स्टेट डायग्राम इज ड्रॉन एंड अकॉर्डिंगली विल राइट द एक्साइटेशन टेबल. अब एक्साइटेशन टेबल लिखने के बाद विल राइट द एक्सप्रेशंस. एक्सप्रेशंस के बाद आप ये फाइनल डिजाइन करोगे. ठीक है. So this is how we design our 3-bit up-down counter using JK flip-flops. This is mod 9 counter. Mod 9 counter, as we can see that mod 9 up counter है. ठीक है. It's just an up counter. This is a state diagram. Mod 9 starts with 0 0 0 0. 9 है तो definitely we know that we need to have 4 flip-flops because 9 can be defined by 4 bits. 4 bits से ही 9 तक जा पाओगे. ठीक है. With 3 bits it is not possible. So we need to have 4 bits. For 4 bits we need to have 4 flip-flops. ठीक है. So 4 flip-flops are required. So here we have designed the state diagram for 4 bit. 4 bit, that is we have all 9 states. We start with 0 0 0 0, goes to 0 0 0 1, 0 0 1 0, 0 0 1 and 1, 0 1 0 0. मतलब 0 1 2 3 4 5 6 7 and 8. So these are all 9 states. Total 9 states. We start with 0, then till state 8. ठीक है. So 9 states तक है. So we have drawn it in this way that it goes in this direction. The direction is this way. ठीक है. Now this is our present state and this will be our next state. Now since it is making use of T flip flop, that becomes very simple for us. T flip flop में या तो toggle होता है या तो no change होता है. That's it. We don't have any cross conditions. क्रॉस कंडीशंस नहीं होता है इसमें. इधर वी हैव टॉगल और वी हैव नो चेंज. मतलब 0 का 0 होगा, 0 का 1 होगा, 1 का 1 होगा, 1 का 0 होगा, 0 का 0 होगा तो नो चेंज होगा. टी विल बी 0. 1 का 1 होगा या 1 का 1 होगा, 0 का 0 होगा तो डेफिनेटली विल बी नो चेंज कंडीशन. 0 से 1 हुआ, 1 से 0 हुआ, टॉगल हो गया. ठीक है. तो हियर we don't have any cross conditions. We'll be having either no change or a toggle state. So here the present state is 0 0 0 0. Next state is 0 0 0 1. So here we'll be writing all the required excitations. And now based on this, we'll write all the expressions for T4, T3, T2 and T1. So T4 is going high for these two combinations. These two combinations only. That is 0 1 1 1 and 1 0 0 0. Now here again we need to take one important thing in consideration, that we are not taking other combinations of 4 bit. हम उन 4 bit के combinations को consider ही नहीं कर रहे हैं. So in that case those will be again taken as don't care. उसको भी आपको लेके चलना है. And then only we will be getting the final expressions. Only not from this, we'll have to consider the other combination, that is from 9 to 15. Those will be don't cares. And then finally we'll write the expressions for T4, T3, T2 and T1. Okay. Now this is how it is designed. चलो.